Cool. All right. So the basic setup, when it comes to adding code, it's really awesome that Arduino has its own software or IDE. So they have their own platform with libraries that you can use that's compatible with their Arduinos. So the basic setup, you have void setup and then these brackets, right? So we're gonna have code in here, and then in void loop, we're gonna have code in here as well. So the setup initializes variables, any pins, libraries, etc., and then the loop executes and loops the command. So quite literally, loop, no matter what, it's just going to keep going and going and going. It doesn't stop unless you tell it to, right?
So where are you
Okay.
clicking? Let them know where you click.
I just clicked on code. Okay. My mouse is hovering over it. It just turned blue. So this is where we're going to be switching up what our circuit's going to do. Okay. You can do blocks like this. I really don't like it. To each their own. For me, it's confusing this way. So I'm going to switch to text. Okay. So here on the top, all right, right below code, blocks, text. Continue. Yes, please. All right. And here's what we saw on the slide. We have void with something already in it, and then loop with some stuff already in it. All right. Pin mode. So here, all right, we are assigning 13, which is not connected yet, as output. So we haven't connected anything, so nothing's going to happen as, you know, what's written down on the loop. So if I connect it now, though, I'm going to move my LED. And let's move it over here so we have more space. Okay. I'm going to drag this. I can connect, right, this row with this row, like so. Okay. Delete this bad boy because, right, this is connected here, but not here. Whoop.
You're in the code.
No wonder. All right. I'm going to, sometimes you have to exit out of it for it to register your keys. Okay.
Do you mind if I say something, Claire, about what we're doing? So what we were doing before is taking 5 volts directly from the board. What we're doing now is in order to control the LED, like we determine when it turns off and when it turns on, we're gonna run voltage through pin 13. So you saw that in the setup, we set pin 13 to output. So that's gonna let it send out voltage through pin 13 instead of 5 volts. 5 volts is just always going to spit out 5 volts. Like it's always just going to be on pretty much. But by moving it to pin 13, we can control pin 13 to turn on, turn off, and we can control the voltage coming out of 13. So that's what's happening and why we're changing it.
100%. Thank
so
you.
I think it would also make sense for you to delete that red line. So now they understand that we're getting the power not from the 5 volts, but from pin 13.
This one right here?
Yeah, that red one.
There we go. Also, by the way, for neatness purposes, I could even like go, where is it here? There we go.
So I think left click allows you to like bend it, and then right click terminates the wire. So I think you need to drag that down to row 3, the end there. There you go.
There we go.
And how about we change the color of that? Like ground is the reason is that you don't want to confuse your positive and negative. So yeah, we typically
The ground is usually,
yeah, black, and power is usually red. So there we go. Just a little indicator. It helps out. When everything is green, you can kind of lose what's happening. So now we're drawing our power from pin 13.
yeah, but we have to connect this loop right here.
And you can make that black if you want to.
There we go. Negative.
There you go.
All right. Sick. So when we actually work with the physical microcontrollers, we're going to have to write this ourselves. Right. It's kind of cool that the website provides this for us. Okay. But I hit start simulation and check it out. Actually, it's kind of hard to tell. Let me switch this up a little bit. All right. So pin mode, we've assigned pin 13 to output. Okay. Now we have digital write. So what digital write is doing, okay, is this is turning on, right, our LED. So high for on, and then we're going to turn it off, okay, low. This delay is how long we're going to be having our light on for. So 500 milliseconds, okay. So I can do 500, I can do the same. Let's do 250.
So what's the impetus for this? Why are you changing it to 500?
So just so you guys can see, so the lower the number, right, the faster it's going to be. So this is when we went from 1,000 milliseconds to 500. So now if I run it, you'll see the blinking lights a little faster.
So I think it'd be good to explain it a little bit more in detail, line by line. So line number 8 turns on pin number 13 and sets the voltage to the highest it can. So I think that's about 5 volts. And then it's going to hold it there for 500 milliseconds. So millisecond is a thousandth of a second. So 500 milliseconds is half a second. So turn it on, hold it on for for half a second. Then in line 10, we digital write pin 13 to low. So that pretty much takes the voltage all the way down to its lowest setting, which is pretty much 0 or off. And it holds it there for 250 milliseconds or pretty much a quarter of a second. So on for half a second, off for a quarter of a second, on for half a second, off for a quarter of a second. So that's exactly what's going on right there. Let's just make them do one more pin on pin 12. That could be like homework right now.
Okay. Yeah.
Homework.
Question for you, Earl. Does this mean anything?
The little tilde?
Yeah.
Yeah, it does. I just don't remember what it means. I have to look at the sheets. Yeah, I guess one thing we can say is PWM stands for pulse width modulation. So what it does, instead of giving you like we can control the voltage that comes out of there, but instead of bringing it down to like from 5 volts to 3 volts, instead what it does, it kind of like turns it on for 5 volts for a little bit and then off for a little bit, on 5 volts for a little bit, off for a little bit. And when you average it out, it kind of averages out to be 3 volts. And that's pulse width modulation. So instead of giving the full 5 volts the whole time, it gives pulses of 5 volts to kind of reduce it down to 3 volts or whatever you want to request. So
I think the tilde it's used for their analog pins. So if you look at the bottom, so digital pins are just mostly like either you're on or you're off, right? It's either you're at 0 volts or 3.3 volts.
yeah. Oh, so yeah, the tildes
And
are
then
the pulse
the
width.
tildes are for analog. So analog would be like if you wanted to give a voltage that's anywhere between like 0 and 3.3, right? So you can give a voltage for 1.5, 1.6. That's what analog means, yeah.
So how about Claire, you start another LED so the people watching can see. Do a yellow LED for me, please. I want to do like a red light, yellow light, green light. Like if we're, you know, how it seems simple, but there's like programming and circuits in street lights. So let's do that.
True. Oh, I have to minimize this. And I have to stop the simulation. Okay. All right.
Oh yeah, you should make them do a street light straight up.
Yeah.
And then have it like one here and then here and then here. Do it. That'd be fun.
All right.
Rotate it.
Okay. So should I? Okay.
Wait, you can't change the color of that LED?
Yeah, I just have to place it first.
Oh, okay, cool.
Yellow.
Sorry.
Yeah, there's a little like box that pops up. You can change the name of it, change the color.